Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is Bitwise end of numbers range. So the problem statement goes like this: given two integers left and right that represents the range left and right both inclusive. Return the bitwise end of all the numbers in this range inclusive. Okay, so let's say the left and right numbers are given to be 5 and 7. Then what you have to return is bitwise end of all the numbers in the range. Okay, so this is what you have to return. Okay, so 5 and 7 both were included in the range, and let's see the constraints. So left and right can be ranging from 0 to 2 raised to power 31 minus 1. Okay, so if we consider a brute force way to solve this particular problem, then we can just loop over left and right. Okay, run a loop from left to right in this range and do bitwise end of all the numbers in the range. Okay, but uh, the number of numbers in this range is equal to 2 raised to power 31 minus 1. Okay, so it is of the order 2 raised to power 31 minus 1. Okay, or you can say 2 raised to power 31. So these are quite high number. This is a quite high number of operations that you will be requiring if you are deciding to run a loop from left to right. Okay, so the number of operations required will be of this order, but these number of operations are significantly greater than the operation limit, which is 10 raised to power 8. Okay, so this is the operation limit. If the number of operations required by your program to solve a particular problem exceeds or become equal to 10 raised to power 8, then you may get a TLE and your solution will not be accepted. TLE is time limit exceeded, so your solution will not be accepted. So this makes this particular thing that the constraints are so large that a linear solution will give you time limit exceeded is the tricky part in this particular question. So we should be devising a method so that we can come around this limitation of running a linear loop. So we need to make some observations here. First of all, let's see the binary representations from, let's say, first 20 numbers would be sufficient to make some observation. Okay, so binary of 1 to 20. Okay, so these are binary representations. So thing here which you can observe is, like, see the numbers which are having same number of digits. Okay, so let's say we try to concentrate on this particular part. Okay, okay, from 4 to 7, let's pick this part. Okay, let me try to take it here, so it's fine now. Okay, I guess this should be working now. Okay. Yeah, I guess it's visible enough. Anyways, I'll be writing it again also here on this left right part of the screen. So this is a number and its binary is on this side. So 5016110 and 7111. So if you see a pattern here, that if let's say the range was from 4 to 7, okay, both inclusive. So if the particular bit is set in 4, which is the leftmost bit, and it is also set in 7, then all the numbers in between will have that leftmost bit set. Okay. Okay, this is the observation here which you can make. So what we can say, if left part of binary representation matches in first and the last number of range, then this left part is as it is present in all the numbers of the range, all other numbers of the range also. Okay. Numbers of range also. Okay. So let's say there was a pattern something like this, and here also it was repeated. So this is your start and this is your end. Then all the numbers in between should be having this particular pattern at least. We cannot say what things will be present here, all the numbers will be in between, but we can say for certain that at least this 101 will be repeated in every number that is there. Okay, so this is a observation that can help us to arrive at an approach that can solve this particular problem. Other than that, why we are considering this common left part. Okay, so you can say this is common left part. Okay, or more specifically you can say that common prefix. Similarly, if you want to extend your observation, you can do so. If let's say we are considering all the numbers having equal number of binary representation bits, so if we consider till here also, so you see that in 8 this is set, and in 15 let's say range is from 8 to 15, so 15 this particular one bit is set. So in all the numbers that are there, at least this part is set. Okay, you can see all the numbers that are there. Okay, so indeed our observation is correct. So let's try to use this observation to come up with the approach that can solve this particular problem. So what we'll be doing is we'll be finding the common prefix. Find the common prefix. So to find the common prefix, we have to somehow, delete whatever part is not matching in these two numbers. So let's say if you were to end 4 and 7, all the numbers between 4 and 7 range, so you have to remove this part. Which part I am talking about? This part, because this part is not matching in 4 and 7, so this part should be removed, this part in 4 and this part in 7. So what we can do is, we can use so those of you who are not familiar with binary operations, there is I'll also try to provide a link of an article where you can read about binary operations. Okay, so I'll try to find something on this, and then what I can tell you is there is a right shift operation which shifts the bits towards right. Okay, so let's say we apply right shift operation, and we shift every bit one by one till two numbers become equal. What I mean by this is, binary representation of 4 is 100 and 7 is 111. So till both numbers do not become equal, we keep binary shifting their bits by one place. Why only one place? Because we want to just stop at a point where these two numbers become equal. So let's do that. After first binary shift towards right, okay, these numbers will be, 4 will be something like this, okay, and your 7 will be something like this. Okay, and you will be counting how many times you shifted their bits towards right. Okay, so after second binary shift, your 4 will be this and your 7 will be this. So right now what we can say is that these numbers are right now equal. So how many times do we binary shifted them? So it was the first time and it was the second time. So we do the binary right shift 2 times. Okay, so what we will do, when these two numbers will become equal, we will pick either of these two numbers and see what is the binary representation we are having. And so 2 was the number of binary right shifts, number of right shifts. So you will simply do number of left shifts, these number of times, number of right shifts. Okay, do a left shifting operation by shifting bits these number of times, number of right shifts. So what you will end up with this this particular number. Okay, so it was 2, so it lead to this particular number, and this is your answer. If you ask me what will be the answer, since there is a property in AND that, let's say there are some binary numbers, okay, and we have to do the AND operation here. So the result of AND of any two numbers will be carried out with the entire AND operations that are there. What I mean by this is, let's say all of these are 1, okay, and you do binary operation here only, so it resulted in 0. Now see, this 0 will do binary operation with 1, 0 and 1 and will be 0 only, and this 0 with this one, so 0 only, so this 0 with this one, 0 only. So this is how this thing will keep continuing. So the effect of a certain bit is spread throughout the AND operation that we will be having. So if these bits are not equal, so they will anyways cancel each other out, and whatever will be the common prefix between the first and the last term of the range, that will be our answer. Okay, so this will give you common prefix. So this is the common prefix, and what will be the equivalent decimal representation? Okay, what will be the actual number corresponding to this binary will be our answer. So let's find the common prefix. Okay, and that will be our answer for sure. And if you ask how many times this particular loop can run, okay, first let me write the logic here, then we will discuss the time complexity also. Space complexity wise we will not be taking anything, so it will be a constant space solution. So what you will be doing is you will be counting the right shifts. So right shift count, while left and right are not equal, so last and the first number of the range. Okay, you will right shift your left by 1 bit, and similar thing you will do for your right, which is the last number for your range. Okay, once you are done with it, you will increase the number of right shifts that you have done, right shift count. Okay, now once you are out of this loop, so left and right both will become equal, so you can pick either of them. Let's say I am picking right here, so you will be returning this right left shifted by right shift count number of times. Okay, this will give you, or let me take it in a variable and let's say common prefix. Okay, so we will be returning this common prefix. Let's try to submit for sample test cases, seeing whether this is getting accepted or not. So as you can see, it's getting accepted for at least sample test cases. Let's submit for the final evaluation. So this is getting accepted for final evaluation, or after final evaluation also. So that is how we'll be solving this particular problem. If you are still having any doubts or any queries in general, then you may ask them in the comment section. Thank you for watching. Have a great day ahead. And yeah, before ending the video, I forgot completely. I'll be telling you what is the time complexity here. Since int is a 32-bit data type, generally it's the case in Java or at least in C++. So there are 32 bits, so the number of operations that will be required will be of order 32. Okay, so these will be the number of operations that will be required. So time complexity, if you take this as a constant, is, you can say, approximately constant, but if you are concerned with a particular threshold, then it's order of 32. And for space complexity, this thing is of constant extra space. We are not using any space here. Okay, so these are the complexities. So thank you for watching again, and have a great day ahead.